All right, hello everyone. The goal for this video is to derive the derivative formula for the inverse tangent function. And we're going to do that by using implicit differentiation. First step we're going to take is to rename this as a y. So we're going to set y equal to the arc or inverse tangent of x. And then we're going to take the tangent of both sides. So we're going to have the tangent of the function y is equal to the tangent of the inverse tangent of x. And because the inverse tangent and tangent are inverse functions, they're going to cancel out for us. And we have the tangent of y is equal to just the independent variable x. We are now going to take the derivative of both sides with respect to x. So we're going to have the derivative of the tangent of y and that is going to be equal to the derivative with respect to x of our variable x. So when we take the derivative of the tangent function, please keep in mind that this is a function of a function. So using the chain rule, the derivative of the outermost function is going to be secant squared of y. So we have secant squared of y. And then by the chain rule, it's times the derivative of the inside function, which is y prime. And of course, the derivative of x is just 1. We now need to solve for y prime. So in doing so, we're going to have y prime is equal to 1 divided by the secant squared of y. And that is recognized as the reciprocal of cosine. So the reciprocal of the reciprocal is just the original cosine squared of y. We cannot keep our answer in this form here because the original problem didn't have y. That was something that we went through and named. So what we're going to do is convert this back into the variable x. And in doing so, we're going to use some trigonometry. So we know from earlier, and it's right above, that the tangent of y is equal to x. So we're going to draw a picture from trigonometry which has this feature. So we're going to draw a right triangle. Remember again that the tangent of y is equal to x. But that needs to be a trigonometric ratio, so let's make it x over 1, which is the same value. And that means that our opposite is x, and our adjacent side is 1. And of course, in this context, the angle is y. So now what we need to do is find that missing side. And we know from the Pythagorean theorem that a squared plus b squared equals c squared, where a and b are legs and c is hypotenuse. So if we take our 1 and square it, and our x and square it and take the square root, that's going to give us our hypotenuse. So therefore, our y prime is equal to that cosine ratio squared. And now the cosine ratio is going to be the adjacent side, which is 1, divided by the square root of 1 plus x squared. And that right there is just the cosine, but remember, this is the cosine squared. So what we have to do now is simplify this down by squaring. And in doing so, we still have 1 as our numerator, but now we've got 1 plus x squared. So that tells us that the derivative of our function, y, which was the arctangent of x, is the ratio 1 over 1 plus x squared.